Well, good afternoon to everyone who's joined the webinar. We're going to get started here at this time. Um, I would like to take just a moment to remind you about Thursday's presentation, where we're going to be doing a webinar on Microwave Pro 2, which is our premier program for doing microwave analysis. If you've never seen it done, and perhaps you even have the program and like to learn a little bit more, make sure you tune in the webinar, which is available to everybody on the list coming up on Thursday at the same time. All right, John Gray is our Director of Research and Development. John is also a Vice President of vSoft Communications and owner, and he has been with us with vSoft for, oh my goodness, almost 20 years if you go back and count it. I didn't know that John was that old, but nevertheless, we're really happy to have John as a partnership in our vSoft communication programs and activities. John is also the author of Probe 4, and we'll let John take it from here. Go ahead, John.
All right, well, welcome to the Probe 4 webinar. We got it called Tips and Tricks, which I'm going to try and do some tips and tricks, but I've kind of decided what we're going to do is kind of run through a study, and along the way I'm going to try and delve into some of the more, advanced features of the program that some of you may have seen or may use regularly, or some of you may not even know they're there. So I'm just going to try and run through a study anyhow to get started off here, and so I'm going to go through this. If anybody has any questions, feel free to put them in the little chat box down there. Also, some of you guys, the mics are on. If you want to, just go ahead and interrupt me and ask a question. If the mic noise gets to be a problem, we may end up muting those, but thus far it sounds okay. So with that, I guess we'll go ahead and get started here. All right, so here we have Probe 4. So what I'm going to do is go ahead and run a coverage study, and we're going to look at a kind of multi-station study and some of the things that you can do in Probe that kind of relate to that, and along the way we're going to hit some of the main features. So I'm going to pick coverage study, hit next on this one and that one. So this window of the wizard here is where we put in our stations to be considered. Now, I don't know if you guys have played with this cull button over here, but that's the first feature I'm going to look at. Of course, you can just add stations to the study using the add button, and that you would use that to add them one at a time. But if you use our cull button over here on the left, that's going to pull up our database cull window. So the way this window works is up here in the top, you specify your requirements for what you want, which records you want to pull out of the database. On the right, you can pick the database that you want to load from. I'm going to go ahead and choose FM. So for our requirements, we can have any number of requirements. And the way this works is, if the record meets all of the requirements, it's going to pull it in. So for example, let's say we're hit add here. Let's say we want to add all of the stations that are in the state of Iowa. So the way we would do that is the field we want to look at is the state. And then for our operator, we want to have contains. You could also pick doesn't contain if you want to pull all the records that meet the opposite of them, some criteria, or you can say begins with if you want to specify like the first couple letters of a call sign or something like that, pull in. There's some cases where you'd use a begins with, but typically you're looking at contains. So for that, I'm going to put in IA. The values you put in here are not case sensitive, so it doesn't matter if you put lowercase or uppercase. So I'm going to say state contains IA, and then I'm going to hit this query button. And when we do that, it's gone out and searched the FCC database and pulled in all the stations where the state is Iowa. So you see we got a list here right at the top. It has results. It tells us it found 456 stations. And we can, of course, scroll down here and see further into the list. You can use these column headers up at the top here to sort. If we wanted to sort by city, we could click on the city. Um, this one's kind of interesting up at the top because it looks like it has a space in front of the city name. But you can scroll down here and see the city. It shows the state and the power. This DA, if it's no, then it's non-directional. If it says yes, then it is a directional station. You can get fairly involved with your requirements. Of course, you can add all these in here, but they all have to be true. There are some cases where instead of matching all the requirements, you might want to have a match any. And for that, we've added this add list option. If you click on add list, you can do some more advanced, you can have like a sub list of match all, or if you set this on match any, for example, if you say we wanted to add all the stations where the channel is 223, and or the channel is 224 or something like that. If you wanted to just add a couple channels and you or say possibly just unrelated, I don't know, this is just a generic example, but so if you pick that and we say OK, and now we do a query, we're going to pull up all of our channel 223s and channel 245s that are in Iowa. So that's sort of how you can build a more advanced query. Obviously, this edit, if you click on edit, it will bring in the editor and you can change your query for whatever's selected up here and remove if you want to take one out. So I'm not really concerned about this channel thing, so I'm going to hit remove and take that out. So to find sort of a set of stations we can work with, what I'm going to do here is I'm going to add, and what I want to do is find all of the records where the word university appears in the licensee category. Now you'll notice there is no licensee selection in the dropdown. So in this case, instead I'm just going to pick record, and that way if the string appears anywhere in the record, then it will include it. So I'm going to say record contains, and I'm just going to put the word university. Say OK. So now when I do a query, you'll see we get about 36 records found. And we can look at our list here, and we'll notice it has this service code, and the services are outlined. You can find that in the manual. It's also in the transmitter information window. It'll tell you what these codes mean, but M is your kind of full service, full power FM stations. X are translators, and then like an L over here is a low power. So you can do some things. So to narrow this down a little bit more, I'm going to go ahead and say, well, we really just want the full stations. So I'm going to add another criteria. I'm going to say service contains M. And if we hit query on that, here we'll notice that it pulled up 20 stations. So I think that's a reasonable number of stations to work with. If we hit OK on this, it's going to go ahead and add all of these into our station list window in the back. Before I do that, I want to talk about just a couple more things on this form. One of them, this load and save button here, these are reasonably new to the program within the last year or two, where you can actually, if you have a query that you're going to use again, you can hit this save button and go, and this puts this into this scheme system that you will see for, like the map cutoffs and the map features and various other things, where you can give it a name and then you can just pull that back up later using the load button. So that's useful. And the last thing is this reference point. If you were to add a field and have it be distance, you can say distance less than or greater than some value. It needs a reference for where to take that distance from. So this is where you would specify this over here on the right. You can put in the coordinates. Or if you wanted to do within a distance of a city or a particular station, you can use these buttons. So for example, if we wanted to, say, load all the stations that are, within some distance of Des Moines, we can go in and load that out of the database. And then if we were to add distance less than, say, 60 kilometers is the value you put in here is kilometers, and we hit query, see it found 6 stations that meet our criteria that are within 60 kilometers of our reference point, which happens to be the city of Des Moines. For this one, I want to have all of the stations in the state, so I'm going to take that out. So now we're down to, or back to our 20 records found. The other things about this, and all of these lists that you see in the program where it has the headers up on top and it's a sortable list, if you right click on those, it's going to pop up a menu. And you can tell it to generate a text report. Say, for example, if we wanted to put this into a word processor or print this list out just in a text type format, you can generate a text report of these windows or of this list. You can also save the data to a CSV file, so that would generate a comma-separated value file that you could import to Excel or something else that contains the data that you see in the table. And then the last option is the printing the table, where it just does basically a generic print of the table. And we have a print button and a text report button down here at the bottom, but like I say, for any of these lists, if you right-click on them, those options will come up. So there's several places in the program where you might find that handy. All right, so I'm going to go ahead and hit OK on this. So now it's going to load a little data, and it's pulled in our stations. The next thing on this screen that I wanted to talk about a little was this match propagation settings button. What that will do is take the propagation setup that you have for one station and apply it to all the other stations in the study. So say, for example, right now I have my system set up to default to the Longley Rice receiver had to use 9.1 meters. Let's say, for example, for this study, we don't want to do 9.1 meters. We want to do 2 meters. So I can change it here, change that to 2, hit OK. Now, if I go into the next station on the list, you'll notice that that one is still showing 9.1 meters. So if we want to have all the other stations in the list without going through one by one and changing it, we want to have them all set to 2. What we can do is click on this first station, which I already set to how I wanted it, and then click this match propagation settings button, and now it doesn't really give you any indication, it just goes ahead and does it. So now if I click on any of the other stations and I go into the Longley Rice, you'll see the receiver height is 2 meters. So that's when you're doing these studies where you're working with a bunch of stations and you want to have everything set to the same settings, that's the easy way to do it. So that's all I want to say about the wizard portion of this. So we've selected our stations, so I'm going to hit next and then finish, and we'll get into our study window. All right, so it's come up with our study. We've got our progress bar up here at the top, of course, and it's going to take a little while because we got 20 stations. So while it's doing that, we can look at the map, and the first thing you notice is we're kind of zoomed in. We're not showing the whole state here, and we'd like to see more. So I'm going to go ahead and put it on our magnifying glass, and then right-click on the map, and I'm going to pick zoom out. Let's try zoom out X4, which will zoom out by a factor of 4. Well, and as often happens when you're trying to demonstrate something, of course, something goes wrong. So, not sure why, but it really shouldn't have paused here. So, I think we're going to have to restart. See if I can close that. All right. All right. Try that again. This thing, it says the program was not closed properly in the last run, however, it may be possible to recover the data. I'm going to go ahead and hit yes here, and we'll see what it comes up with. It may yeah, that actually loaded another study that I was doing earlier, so I'm going to or it's actually the same study we're doing now, but the trial run from earlier. So I'm going to go ahead and reset this up. Coverage study. And I'm going to fly through this real quick since we already just did all this. I have to pick FM, pick OK. We're going to set our receive height to 2. All right. So we're back to where we were. I'm going to try this again. We'll say zoom out X4. All right, so now you'll see it's got the signal for some of the stations, although it hasn't completed them all. But now we can kind of see where the state is with respect to this and where all our transmitters are. So one of the things I want to do in this study is compare the Longley Rice coverage with the sort of contour style coverage. We want to look at both of those, and just to make it more interesting, or to add an extra challenge to this, our end goal here. Let me pause for a second. It says our signal calculation complete. Do we want to redraw? I'll say yes. Our end goal here will be to generate numbers in a map that only show Iowa and don't necessarily count the area that's outside of Iowa, which is a little tricky, and there'll be a couple steps in here, but it's a doable project. So the first thing I want to do here is I've got all our stations. I'm going to go ahead and add the 60 dBu FCC contour to all those. Now, of course, I could right-click on each one and say Add, and put in the contour and say OK, and then say OK again, and add them that way. However, that is doing it the long way. What I'm going to use is we have a tool which is called the multiple contour tool. And if you go to Tools and pick multiple contours, or if you look up in our toolbar up here at the top, there's a button for the multiple contour tool. So if we click on this, it's going to bring us in here, and we've got a list of all the stations in the study. And what we can do then is tell it to add a contour, and you can give it the properties of the contour. Like I said before, we want the 60 dBu, so that's good. You can tell it to use the transmitter color, which refers to this color in the list here to color contours, or you could make them all the same color by choosing Use Specified Color. I'm going to pick the transmitter color. And then there's some options for the line width and the number of radials and various other contour properties. So if I select that, for every station here in the list, it's going to go ahead and add that contour. So I'm going to click on the Add Contours button. And now that I did that, you'll see on our map we've got all of our contours, and these are color-coded by the transmitter list over here. Just a note on this window here, you can also do, if you don't want to do FCC contours, you can do circles. If you want to do a fixed distance circle from each station, you can do that. If you're working on TV, you can pick the TV protected contour. In that case, it'll use the dipole adjusted contour value, or you can add this primary grid-based cutoffs. This is actually a fairly new option to the program. Actually, I'm going to put those on there just to show you what that looks like. So before I do that, I'm going to hit this Remove Contours button down here, and that's going to remove all of the contours in the study. So if you do that, hit yes, you see our contours went away. So now, contours to add. This will add one contour for each primary cutoff, and you can choose to use the colors. So if we have this checked, it's not going to use the transmitter color. It's actually going to use these colors that we've specified down here for our Longley Rice cutoff. So if I say Add Contours, you'll notice now we've got kind of a crazy looking map because it's got a lot of contours on it. Let me close that out and zoom in. All right, so now we've got, the contours that the red contours are 100 dBu, and this kind of orange contour is 80, the light green is 60, and the blue is 40. Um, so that's another way if you want to just add, equivalent contours to the stations. And you don't have to have a multiple transmitter study to do that. If you've just got one, of course you can go down here, pick this, and it'll add all the contours. Now, I'm going to go ahead and remove all those contours we added because for this study, we really are only concerned with the 60 dBU. So I'm going to put that back on. Still use our transmitter color. So just of note, if you were to uncheck a couple of these, when you hit add contours, it'll skip those. And so there's a couple buttons down here. You can select none, select all, or select map. If you select map, then it will pick whatever the same things you have checked over here, which happens to be all of them. But that's a quick way to add, several contours to one station or several contours to a bunch of stations, or whatever you need to do. So back to our study. Now we've got a Longley Rice view of our stations, color-coded here by field strength, and we've also got the 60 dBU FCC contours. So at this point, say for example we want to, count our population, see what the population is with, and compare between our 60 dBU Longley Rice and our 60 dBU FCC. And that, of course, we can easily do. There's two different things we need to do that, actually. As far as the Longley Rice are grid-based, all we got to do is go up here to report and say population, or alternatively, there's a button on our toolbar for the population report. If we do that, we can put in a field strength, pick our style of report. And the one thing that is different on this compared to a single station study is we want to consider all of these stations kind of more as one big network. So where there's overlapping coverage, you only want to count the population in that area twice, or not twice, you only want to count it once instead of twice. So the way you do that is there's a checkbox here that says treat all transmitters as one superstation. So I'm going to check that, and I'm going to go ahead and use our 2014 census estimate. And when I say generate, it's going to pop up a second window which lists all of the stations that we're going to include. So at this point, if there were some stations you wanted to leave out of the count, you could uncheck this box. And also, if you're working on a situation where you have, some stations you want to consider the 60 dBU and some stations you want to consider the 54 and so on, you can actually select stations to change. It defaulted them all to 60 because that's what we told it. But say, for example, if we wanted to change that one to 54, we can just type that in there, and you see it changed that to 54. I don't really want to use 54 on this one, so I'm going to change it back. But that's how you can do that. You can look at multiple different cutoffs for different stations. And then it gives you the opportunity to set the call sign for the superstation is what they call it. So I'm going to go ahead and click OK. All right, so here's our report. Basically, it gives you, a list of all the stations you considered and what field strength you're considering. And then, of course, your standard population report. So we can see within the Longley Rice, 60 dBU, we got around 2.5 million people, around 1 million housing units. So I'm going to go ahead and keep this open. So this is for our Longley Rice. Now, if we wanted to get a report that's basically the same thing, but using these contours instead, what we need to do is generate an overlap area. So for that, we have another tool. And the point in generating the overlap area is to create a union of all of the stations so that it kind of considers them as one, big block of stuff. So to do that, if we go to Tools, there's Contour Overlap on the menu. And then, as with most of our other features that are commonly used, there's also a toolbar button. So that's up here, our Contour Overlap button. If we go ahead and click on that, and we hit Create New Overlap Region. So for our overlap region, you got to tell it what all the contours you want to consider are. And there's two types of overlap regions. You can do an intersection or a union. So an intersection is where it'll take all the area that is common to all of the contours that you put in there, and that's what it will consider. Or if you do a union, it will take just all of the area that's encompassed by all of the contours that you put in. So in this case, we're looking to combine all these, so we want to select union. And then we're going to want to move the contours over into our overlap region. So the way this works is sort of the available areas are listed over here on the left, and our region is listed over here on the right. So right now we have nothing in our region. So say, for example, we want to add, and for each of these, for each station, you pick on it and it shows the available contours. So if we had several contours for each station, they'd all show up in this list. So we can move them over using this arrow button. If we click on that, then we've added KBVU, and we can go to the next one and add that, and we can go to the next one and add that. But as you can see, for this situation where we've got 20 stations, it could be kind of a long process adding them each one at a time. So there is a easier way. So I'm going to go ahead and hit remove all, and this is going to take all of the contours that we had in our overlap region out. And then I'm going to look down here, and there's a button that says add all areas in study to overlap. So if you click on this, it's going to go ahead, and all of the available areas in the study lab or in the study are going to go into it. And what counts as an available area is a contour or a polygon set that you've added to the map. Thus far, we haven't added any polygons, so the only thing in the study is contours. And so you can scroll down the list here, and you can see we've just got one contour for each station, which is what we wanted. And then we have this checkbox for the auto name feature, so as it added all those, it actually added the call sign and channel for each station into the name. For this case, since it's a lot of stations, we may want to just go ahead and replace that. We'll just say, we'll give it the name of all stations or something like that. The name doesn't really matter, it just shows up in the next list. But and then down here at the bottom, there's some options as far as plotting goes. You can tell it a color to plot in. There's a checkbox for whether or not it's on the map, and there's an option to plot transparently. Now, when you're building these overlap areas, I find that it's very useful to, before you do anything with them, just to go ahead and plot them on the map and make sure that the area that gets filled in is really what you want. Because it's easy to select the wrong station or do the wrong thing there. So I'm going to go ahead and hit OK. So we've defined our area, we called it all stations, and I'm going to hit close on this window, and it's going to go ahead and draw a map of a plot of what we've selected here, and I told it to plot in red. And there it is. So you can see the area in red here. When we do a pop count for that overlap area, it's all this stuff that's in red that's going to get included. And I'm going to go ahead and turn off our grid-based signal, and I do that by clicking this None button here, which unchecks all of these boxes. And each of these boxes over here, just in case you weren't aware, toggles whether or not the signal, the grid-based Longley Rice signal, is plotted on the map. So if we uncheck all those and then click on our Force Map Redraw button, then we'll get a map that just shows the overlap area. All right, so now if we want to get a pop report for all this area in red, the way we can do that is go back to our contour overlap region list, and we'll pick the area we're interested in, which is all stations. And we'll say population report. There's a button right here. So if we click on that, and then we pick our database, I'm going to say OK. It's going to go ahead and load the data and count the population. And this one automatically gives you a county breakdown as well. Okay, so what it's doing now is actually there was an option that I had turned on there, which we don't necessarily need in this case, but it's counting the individual contributions of each area, so that's why it's kind of counting over and over again there. But overall, and that's what this stuff, the contributions of each area to the total. For this one, we're not really that concerned about it. We really just want to look at the total, which, if we want to compare it to our other report, which I minimized, this is worth noting up here. If you want to get back to that window, which I didn't close, I just minimized it, there's a little pull down up here in the upper right-hand corner of the main window. And it won't let me access that right now. And the reason for that is because this window behind this, our contour overlap region, you can't access that in the main window at the same time. So I'm going to have to close on this one. And now if I pull this down, it'll have our texture output, which was our first one that we ran, and then text output 1, which was the contour report. So you can see here, these are actually pretty close. The Longley Rice was 2,513,000, and within our 60 dBu contours, we had 2,553,000. Noting that the Longley Rice was calculated using a 2-meter receive height. If you had calculated that with a 9.1 meter receive height, it would be probably somewhat higher, at least as far as the Longley Rice population. And then the housing units are also pretty similar. They're both right around a million. This one's 1,089,000. This one's 1,107,000. But that gives you an idea. Now, when I started this study, I said I was really just interested in the coverage that exists within the state of Iowa. I don't really care about outside of it. And both of those reports that I just generated are showing total coverage. It doesn't know anything about any kind of border limitations or anything. So now I'm going to show you guys how you can actually go and put in a border that you want to limit these things to, and then generate a map and a population count that reflects that. So in order to do that, what we need to do is add a polygon that represents our border. Of course, we could manually create a polygon, but for something like the state of Iowa, that would take a long time if you want to do it accurately. So the program has a feature that allows us to load this from our mapping data. So the way we access that is we go up here to Map, and then Add to Map. And down here at the bottom of this little pop-out, there's a couple polygon-related things. There's Polygon for map data, and New Polygon and Polygon Set. Now, we could use this Polygon for map data, but that allows you to load a single polygon, which for this example actually would work, but for a lot of times, if you're looking at a city or something that's a little more complex, there'll be kind of pockets or multiple polygons that make up the whole area. So typically when I'm going to load something out of the map data, what I will do, instead of using this polygon for map data, I will go to this polygon set option. And a polygon set is essentially just a group of multiple polygons. Like I say, I usually go to this first because I don't know if the area that I'm going to consider is one polygon or more. So when I pick polygon set, it gives me this window, which essentially there's your plot properties on the left, and then over here on the right you've got the list of polygons that are in this. Right now we don't have any polygons. We could add, if we wanted to type one in, we could hit this add button and insert the points and type them in. Not interested in doing that today, but that's an option. This get from map and put to map. If you had a single polygon that was on the map that you had already defined, you can use those buttons to add it to the set or take one out of the set. For now, we're not going to mess with this. This from data is the button that we want to use right now. So if we click on from data, it's going to pull up our polygon load window. And in this window, there's a drop-down where we can select any of the data sets that have a searchable component to them. Some of the data sets we have do not. They don't have any kind of name information with the data, so there's no way to search it. But a lot of these U.S. Census-based data sets do, so we can go through here and pick, we could do a city, or we could do an urban area, or a county. This county subdivision is just kind of general areas within a county that may not be actual cities. If we go down, we'll see there's a state data, and there's two options. There's a high res and a CARTO. Basically, the high res is a higher resolution. However, for the purposes of this study, the CARTO, which is just the general cartography data, I think will be sufficient. And it basically operates a little faster because instead of, with the high-res data, there's considerably more points, but usually the points are in a straight line for the most part anyway. So I'm going to pick the CARTO data just so it runs a little faster. And then down here, there's this find window. So it shows all the polygons here, and I can type in find. So I want Iowa, so I'm going to type in Iowa into the window, and you see it brought that to the top of the list. So we'll see here Iowa only has one polygon, which is good. And then these coordinates here are shown are kind of the center of the polygon. So if it's a deal where there's more than one, you can kind of use those to kind of pick which one it is. So I'm going to hit OK. And so you see now it's added my polygon to this. And so we've got a pen style. This is going to be how it's drawn. So I'm going to take this and go ahead and set it to be, I think we'll leave it black, but we'll make the width to be 3 so it stands out on our map. We also have the option to fill the polygon on the map. Actually, I'm going to turn that on just real quickly right now so we can look at it. I'm going to make that yellow. And now I'm going to hit OK. And you'll see here, it's got our polygon, but it's not filled in. And the reason it's not filled in is because there's an option here for the plot layer, which is below the backdrop. So in order to fill it on that layer, the whole map needs to be redrawn, which is fine. And one other thing I'm going to do is go back into the properties for this. And I'm going to, real quick, I'm just going to reload it because I noticed, oops, one of the things you can do, actually I'll just talk about this. When you're working with your map, when you select it, it shows these little black boxes, which are all the points that define it. And to get back into that editor thing, if you double click on one of those black dots, it's going to pull this in here. But it's very easy, as you're double clicking, to kind of click once and then drag the mouse, and you'll end up pulling one of these dots out. And that will affect your polygon. You're going to get a different pop count. It's going to mess some things up. So there's a way you can stop that from happening. So I'm going to go ahead and remove this polygon, because what is in here now is this modified thing where I dragged a point. So I'm going to go back and say from data. It's already there because that's the last thing we loaded. So I'm going to load that again, and now I'm going to click this box down here at the bottom that says lock points in place. This will prevent us from dragging the points around by accident. So if I hit OK, now if I try and drag one of these points with the mouse, it's not going to work because I had locked them. And if we do a redraw, if I click force map redraw, then we're going to see it filled in like we told it to. And there it is. So, and this is another one of these where sometimes it's a good idea just to fill it in so you can see what area you're talking about. Now, since I'm not really interested in having it filled in, I'm going to uncheck that and hit OK. And it's still filled in right now. When the next time we do a redraw, it'll come up as white, which is fine. And you'll see we've got a nice dark border here, so we can see where the border is. So the first thing, since I've got our overlap area up here, I'm going to work with that first. So the question is, how do we not count this area that's over here, and not count the area that's over here, and not count this area that's down here in Missouri? And the way we do that is we can actually add a limit to our overlap area. So I'm going to click on the overlap button here and double click on the name of the area I want to edit, which is our all stations area. And now you'll see, since we added that polygon, down here at the bottom of this list there's a PLST, which stands for polygon list. So if I click on that, it's going to show all of our polygon lists that are in the study. Right now we just have this one, which is called Iowa. So now if I were to add this into the area using this arrow button, I'm going to add that, and you see it's down here at the bottom. And I'm going to hit OK and close on that. We'll redraw and we'll see what that does. And I can tell you that it's not going to do what we want it to do by doing that. But this is, once again, one of the reasons why it's good to look at it. So now we just added that polygon to the union, so all of the, it's going to include all the area of Iowa, but it still has the area outside. So what we really need is to insert that into our area, and I still had this auto name turned on, so it renamed my area. I'm just going to leave that for now. So I want to take this area out that we had put in there. So I'll say remove, I'll select it in the list, say remove selected. So now we've just got our stations in there. And now I'm going to go back and pick our area in our polygon list. And instead of using the arrow button here, I'm going to use this next button down, which says lim. And if you hold your mouse over there, it tells you what that means. It goes away after a few seconds. It says add selected area as a limiting area for the overlap region. And so what that'll do is essentially this polygon then will become a bound for all the other things. So it's going to include anything that's in that polygon, but the stuff that's outside of it, it won't. So I'm going to click lim, and what that has done is added it to our list, but you'll notice now instead of just saying, you know, plist Iowa, it says limit next to it. So it's added that as a limiting polygon. So if I say OK to that, and close, now we're going to get a map which will hopefully show what we were looking for, which is the 60 dBu FCC contours, but limited to the Iowa polygon. And sure enough, you'll see that now it's no longer filled in these areas that are outside of Iowa. So when you run the pop report on this, which we go back up here and we'll just go ahead and run pop report, and I'm going to uncheck these options because we don't really care about those right now, and we'll pick 2014. All right, so now we have got total population 2.3 million. So if we compare that to, and this one is our Longley Rice one, so we don't want that one, we want the other one. So if we compare that to the numbers we got before, when we were allowing the area that was outside of Iowa, we saw that there was, you know, a little over 2.5 million, and now we've got, you know, 2.34 million for the area that is limited to just within Iowa. So that's effectively, you know, this 2.3 million is the number that I kind of said we wanted to find, and this is just for FCC contours. So now, the next step on this would be to go back and say, okay, well, we've done it with the FCC contours, that's nice, but what we really want to know now is also the Longley Rice. How do we count, you know, the area within Iowa that excludes everything that's outside of it? So to do that, the first thing I'm going to do is go in here and turn off the plotting of our overlap area that we've just looked at. I'm going to keep it in the study, but I'm going to turn it off so we don't have to look at it. There it is. And so now I'm going to click on this all button so we can see our Longley Rice again, although at this point it doesn't necessarily matter. So the question is, you know, how do we limit our pop count for our Longley Rice to the area just within Iowa? And there's an option for that. It takes a couple steps to get to it, though, to get to the final number. So you notice if we go to our standard grid-based population report by clicking on the population button up here, there's a little option here, only count area inside overlap region. And it'll show all of the overlap regions we've created. Now, we don't, you know, if you wanted to limit it to within those 60 dBu contours and all that, you could pick this area, but that's not really what we want at this point. We just want to limit it to Iowa. So what we need to do is go in and create a new overlap region that just includes Iowa. So I'm going to do that. I'm going to click on contour overlaps and say create new region. I'm going to scroll down here and pick our Iowa polygon and move it over into our region. At this point, since there's only one polygon, it really doesn't matter if we pick intersection or union because it's going to include the whole area. So if I hit OK on that and then close, and you notice I left that on plotting. So it's going to fill that area in, and we can make sure that it's the area we want. Of course, it will be covered up by the signal mostly here. Well, actually, it's going to come up on top of our signal, so it actually works out. So we can kind of see this is the area then that we're going to limit to. So if we go in and say back to our pop report, and now we pull this down and pick this new overlap area that we called Iowa, and we want to check this box for treat all transmitters as one superstation, so they're all, all considered together instead of separately. If you don't check this box, of course, it will give you an individual report for each station, and there's no relationship between them. But if you check this, it treats them as one station. And once again, we have our window where we could set our different cutoff levels. We don't care about that, so I'm just going to say OK. All right, now we've got our text report here, and we can see, let me load up our first one. I'm going to put these side by side and compare them. We can see now in our limited to the Iowa polygon one, we've got 2,291,000, whereas before we had 2,513,000. So the difference there is the number of people who are outside of Iowa, and same thing with the housing units. So that's basically how we can generate the pop report that represents that area. The last thing that you might want to do that would be cool is to generate, how when we had our contour overlap region, we were only plotting the overlap within Iowa, and it was showing up as white outside of Iowa. The question that you might ask is there a way to generate a similar map with the Longley Rice? And it can be done. And this is one of these things where, the tools that are built into the program, like the contour overlap thing and this stuff, they're really kind of designed to be general purpose, so you can actually look at, there's some flexibility so you can possibly get in and do some things that the program may not have originally been kind of designed to do. So, so in order to not show this blue coverage area that goes outside of Iowa and just show within Iowa, what we can do is actually create another overlap region that's going to essentially cover that up. And the way we can do that is by using, I'm going to define a polygon that's bigger than the state of Iowa, and then I'm going to generate an overlap region that includes the inverse of our Iowa polygon, which would be everything that's outside of it, and then the area contained within. We have to give it some kind of boundary to work within, which is why we have to draw a polygon. So I'm going to go ahead and use my polygon tool here, which, let me minimize that. Up here at the top, there's a polygon drawing tool. And if we select this one, then we can define our own polygon just by clicking on the map. So I'm just going to click 4 points that are kind of way out here in the corners of our map. So there's 1, 2, 3, 4. And then I've got our 4 points defined. So if I did those by left clicking with the mouse, if I right click now, it's going to close off that polygon back to my first point. So now we've got a polygon defined on the map that's just sort of an area that's bigger than the area we want to consider. And if we double click on that, of course, it shows us this. So it has a name. It defaults to just the generic name of polygon. I'm going to call it big area. All right, and I'm going to say OK. So now what we need to do is go into our contour overlaps. And I'm going to go in. We have this one for Iowa, and I'm going to turn that off. The plotting anyway. I'm going to uncheck the plotting for that. And now I'm going to add another overlap region. And so for this one, what I want is to include um, this big area, which you see that's under Pgon because it's just a regular polygon. So I want to include our big area, and I also want to include all of the area that is outside of Iowa, our Iowa defined polygons. So the way I do that is I go down to plist and select our Iowa polygon set. And now the second button, the one that's below the limit button, this INV button, it says add the inverse of the selected area to the overlap region. So that's going to add everything that's outside of the polygon essentially. So if I hit that INV, you'll see it says inverse of the Iowa polygon. So, and in this case, we want the intersection of those. And I'm going to go ahead and plot that in red at first, just so we can see what that looks like on the map. And there you go. We've got this sort of red area covering everything up. So now if I zoom in, I'm not going to see the borders of that polygon I defined. I'm just going to see the state. And then if we change our polygon area, there's a couple interesting things we could do with this. If we go in and change this outside of Iowa area and make that white, which is the same color as the background of our map, and we redraw that, you'll see we're going to get a map that basically shows kind of this limited to Iowa type coverage, kind of like we had with the contours. And there it is. Another thing you might want to do, which is also kind of an interesting visual effect, would be to go back into our contour list, go back into this big area again, and instead of making it white, we'll make it, say, light gray, and then we'll turn on this checkbox for plot transparently. And if we do that, we're going to get a map that shows basically the area within Iowa will be in color, and the area outside of it will be basically kind of black and white. So you get a map that looks like that. So you can see where it has coverage outside of the state, but it makes a delineation there between what's in the state and what isn't. And I think that's a fairly attractive map. So that's sort of some advanced things you can do with this contour overlap thing that you may not have thought of before. And ideas of how you can do these sort of limiting studies and such. There are some more things we can do with this study that are probably worth talking about. One of them is, okay, so we've got this map now, and it's got our Longley Rice, and it's got our contours, and say, that's nice, but I really don't want the contours on there anymore. There's two ways you can get rid of those. You can either go back into this multiple contour tool like we had before and click this remove contours button, which will get rid of all of them. You also have the option of turning them off individually. If you right click on any of these, it'll bring up the contour list window for that particular station. If you uncheck the box, let me move this out of the way so when I hit close, it's going to, there it says contour that was around this station just disappeared. That way the contour is still in the study and it's still calculated and you can still do stuff with it. It's just not shown on the map. There's another way that you can get in here. Once again, this is another working with multiple stations thing. There's a thing called map commands, which allows you to kind of turn them all on and off at the same time. So if you want to use that, you go into your map menu and you go down to about the fifth item, which says commands. And then the second item, show/hide. And then you've got some options here. You can hide all contours or show all contours, hide all call signs, show all call signs, and the last one is hide and show transmitter tokens. So if we wanted to just hide all the contours on this map, we can just click on hide all contours, and there they go. And if you really weren't interested in having the call signs, you can also turn those off easily just by saying show hide and hide all call signs. which will just leave, your transmitter locations, and you could turn those off as well. So that's a handy feature when you're working with a study that has a lot of stations in it. Some other things that you may find useful when working with multiple stations, there's an alternate draw mode, which if you click on the display options button over here on the right, or you'll also find this on the map menu down here at the bottom, display options. That gives us sort of a list, and you can go into this and change multiple things at once without having to redraw. It also gives you a selector for the signal display mode. So right now we're in field strength mode, so we're plotting field strength. If we drag that down, there's some options here, and most of these are either special case, like the time delay interference. This line of sight and shadow depth, you would use those if you were not using Longley Rice. If you're using a line of sight as your propagation model or shadow depth as your propagation model, there's a couple special modes for plotting those. I'm going to pick transmitter color, though, as a coverage option. And so if we hit options for that, it'll show us what we got. So you can set a minimum field strength to show. So out here I was showing down to the 40, so I'm going to go ahead and change that to 40. This difference threshold, I'm going to come back to that in a second. And then there's an option to interpolate signal values, yes or no, and then plot method, highest field strength or order in the transmitter list. So I'm just going to keep it on highest field strength. So when I set this and say OK and then OK again, it's going to redraw our map. And instead of showing our cutoffs like we had before, with the field strength, it's actually going to color code the cells in the study by the color that you see over here in our transmitter list. So, you can kind of draw a map, and so this is showing essentially which transmitter has, the highest field strength at these points. You can add, if you want a legend for this, you can add that to the map by going up to Map and say Add to Map, and there's a transmitter list. So if you pick that, it's going to show all of our, for example, we probably don't necessarily want this one. And actually this brings up a good point. Right now I have a Bluetooth keyboard that has to wake up if I haven't used it in a while. So I was going to click on this and hit delete, but if you want to delete these, also when you have an object selected on the map, and this is also a somewhat new feature within the last few years, I think, if you right click on the object, it actually pops up a menu and you have the option to duplicate the object or copy it or delete it, and there's move to front, move to back. So if I wanted to delete this, I could just pick delete. That move to front and back is kind of useful if you've got two things and you want to pick which one is in front. Right now our text legend is in the back. If we want to move that to the front, we can right click on it and say move to front. We'll pull that up to the front. So right now though, I'm basically just interested in deleting that, so I'm going to say delete. And on this map, having the field strength cutoffs on there doesn't mean much either, so I'm going to delete that as well. And then I'll move this over and put it into place on the side. So that's another view here, which when you're working with multiple stations, you might find interesting. If you go back into the options for that, there's also, you'll see this difference threshold. This is kind of a special case thing, and in a situation where you've got a bunch of stations like this, it doesn't make a lot of sense. But if you're just looking at a couple stations or like a booster type situation, and you want to know where the signal strengths are close or within so many dB, so effectively you've got the same signal from each station, you set a threshold. So for example, if we say within say 6 dB, and then you can set a color to plot those. So I'm going to go ahead and pick black because I think it's the only thing I'm not using. Say OK, and then OK again, and now it's going to fill in the areas where two transmitters are within 6 dB of each other in a third color. I shouldn't say a third color, in alternating. So all this black area is where you've got at least two transmitters that are within 6 dB of each other. Not necessarily useful in this study, but I just wanted to point that out in case that's something that you may have a use for. If you're trying to decide, if you're looking at a proposed site, an existing site, you want to kind of highlight where the signal is going to be about the same for each, you can use that to do that, or you know, you can use this mode to kind of highlight improvements and such. So that's the, I'm going to go ahead and switch it back now to our field strength mode, so I can talk about another thing that is new in Probe 4. You know, not necessarily new. It was introduced at the time of Probe 4, and that's the ability to, right now we have all of these stations set to use the same cutoff setup. So everything's going to use those same colors. Now, you may be running a study where you want to have some stations use, you know, one set of colors, and some other stations in the study use a different set to kind of contrast the difference. So the program's set up and you're able to do that. And just to show you how to do that, I'm going to pick like a station here. Let's see which one this one. This one's KNSK. So let's go ahead and set the cutoff set that we're going to use for that to something else. And the way we do that is we can go down here to our cutoffs, and we'll pick that transmitter in this list. So we had KNSK. So I'm going to pick that, and then you pick which cutoff set you want to use. And so there's a default set that's in your study from the start. It's called primary cutoffs, and that's what it's set to. If we click on this little arrow button here, we can actually create a new cutoff set, which it will use for that transmitter. And you can either, it defaults to naming it the same thing as that transmitter, or you could call it, you know, I'm going to rename it to alternate set. And then you get the opportunity to set it up. And I'm going to go ahead and it gave us 100, 80, and 60. I'll go ahead and add a 40 in there just to add that. We'll make that black just so it's something different. Say OK. Now you see I hit OK, and you see this legend changed because that's what transmitter we have selected. If we were to select another transmitter, it will change the legend to reflect that. And it didn't redraw right away. The idea there is you may want to make multiple changes on this, and you don't want to wait for it to redraw after each of them. So it doesn't automatically redraw, but all you got to do is click Force Map Redraw, and it will go ahead and redraw with our new settings. So now you can see all of the transmitters are using our main cutoff set except for this one, which is using an alternate set of cutoffs. And you could assign that alternate set to other stations. So for example, this one that's down here by Iowa City, KSUI, if we wanted to also use our alternate set with that, all we need to do is select it in the list, KSUI, and then now, since we already created that second set, I can just change the set from primary cutoffs to alternate set, which affects just this station. And now we'll do a redraw, and it will use those colors. And there we are. So I think in terms of plotting the field strength, that's probably all I wanted to talk about. There's a tool that you can use, which is this little crosshair tool. It's one of our interactive map tools. We call it the map information tool. As you move this around the map, down here, if you look at the bottom of this window, it's going to show the coordinates, it's going to show the elevation, it's going to show the type, land cover type, and then right here, if you're over the map where there's signal where there's signal for whatever station, sorry, whatever station is selected in the list is what is shown down here at the bottom. So, for example, I'm going to select KSUI. So you notice when I go over that, now it's going to show, I'll stop moving. If you look down there, it shows 89.07 dBU. So this way you can kind of get a feel for what the field strength for one particular station is as you're moving around. If you wanted to know the field strengths for all the stations, if you right click on the map, it's going to pop up a window and you can pick Show Extended Information, which now this is going to create a new window that as we drag the mouse around, If it says in C, that means that the signal was not calculated at that point for that particular station because we had set a fixed, I think on this study it was 125 kilometer, how far out to calculate type radius. But if it has a number, then it's showing the field strength. So you can kind of get an idea of the field strength of all the stations at wherever your cursor happens to be. There's if you check this box at the bottom, it'll actually sort by field strength. So as you move the mouse around, it's going to show you whatever station has the highest field strength. So at this particular point, WOI-FM has the highest, and KUNI is the next highest, and so on. So that's sort of a little feature that's a little bit beneath the surface. You may not have noticed.
How did you get to that feature?
What's that?
How did you get to that feature?
Sure. You go up here and select this map information tool, right? And when you're using that, if you right-click on the map, it's going to pop up a menu. And on that menu, the first item is Show Extended Information. So if you select that, that's when this window will pop up.
Thank you.
Yeah, no problem. Yeah, on any of this stuff, yeah, I know I have a tendency to go a little bit fast. So if you miss something, make sure you stop me and tell me tell me to go back to it, because that can happen. Yeah, so that's our extended info feature. And the last thing that comes up from time to time, I get asked this, is so we've got our list of transmitters over here, and right now it's basically just in the order in which we loaded them from the database. And sometimes, maybe you want to show certain transmitters at the top of the list because they're more important or relevant to what you're doing. So the question is, can you change the order of the transmitter list? And the answer to that is yes, you can. And to do that, you've got to go up here to the View menu, and then down toward the bottom there's actually an option for Transmitter List Order. So that will show us a list of the transmitters as it stands now. So for example, this KSUI, which we were going to say, that's one we want to be at the top of the list. We can select that in the list and then use this top arrow button, and that'll put it right up at the top. If you select something and use either of these middle ones, it'll just move it, one space up or down. So this is a way you can get in here and modify the order of your transmitter list. And if we hit OK, now you'll notice this updated, and we've got new transmitter list, and it has to do a redraw, but have the same map as we had before. But you'll notice that our legend over here, actually, which is dynamic, if you change the transmitter list, this will update as well. So you don't have to manually re-add it or do anything with that. Sometimes on these, you might be zoomed in to a specific area, and I'm going to go ahead and zoom in. If you've got a map and you say, here's one of our transmitters, and say I want to go in and look at a particular, like this KSUI, I want to see that as the center of the map. You can quickly change the center of the map. I mean, you could zoom out and then find it and zoom back in and all that, but a quick way to do it is you select it over here in the transmitter list, and then down here at the bottom there's this little button with an M on it that says Move Map Center and Location to Selected Transmitter. So if I wanted to go to the KSUI transmitter side, I just need to select it in this list and then click this little M button. And there we are. There's the, it's using those alternate colors that we defined, and we're centered on that one. Another little shortcut type of thing, and this is so I'm kind of at the point where as far as the multiple station project, I've pretty much done everything that I was thinking of doing for that. Now I've got a couple other just sort of tips and tricks. If anybody has any questions, and I had one question: can I maximize the program on my screen? I can. But part of the issue with that, actually, I'm going to move it back here. This GoToMeeting actually has a little window off to the side which shows me when people comment on things. So I don't want to cover that up on my computer. So hopefully this will work out for you. So now I'm just, like I said, I've got a few just sort of general tips and things like that M button. So another little shortcut that you can use to get at, for example, if you want to modify our map scale, but you want to go to a specific scale and type it in, or you want to change the map projection, you can do that by going to Map and then Map Projection Settings. There's also the alternate way to get into that is if you go down here at the bottom of the screen, it says Scale 1 to 1 million. So if you click on that, it's going to pull up that same map setting. So here you could set your center coordinates and you could set your scale. So if you wanted to say go to a specific scale. I don't know why you'd want to use this scale, but I just want to type something in that was similar. And then you can also change the map projection here. Typically, the Lambert azimuthal is the projection you use. The time when you might not use that is if you're trying to make a map that's really zoomed out or closer to the North Pole. Sometimes the map projection can run into troubles there, and in those cases you may want to try like the cylindrical or the Mercator projection for very large scale maps. That typically will do better in that situation. So that's how you get to that. So I just changed our scale just slightly to 1,050,000 just to show you how to do it. Another question that comes up from time to time is, how do I move a station? We've loaded these from the database and say, I've got a point in mind, or I'm just looking at the map and I say, well, what if this guy went over here? So for example, this one is still this KSUI. And you can find that out if you click on it, or you double click on it, it'll bring up the transmitter editor for it. And that's also just a little tip that you may not have run into. If any of these, if the call sign's on the map or the transmitter token is on the map, if you double click on those, it'll bring it up in the transmitter editor. And on the token tab is where you can set whether the token is shown, or if I want to say show the call sign, I'll hit OK. And so now we can see our call sign is on the map as well. So if we wanted to move this station, the way we would do that, we actually use the same map information tool that we were using before to show extended information. We can pick a point that we want to move to. Say, for example, we wanted to move it over here. We can do that, and then you right-click on the map. That brings up this menu. The show extended information is the one we looked at before, but if you scroll down or you go down a little bit, there's Move Transmitter is the last one on the list. So if you pick that, it pulls up our Move Transmitter window, and it has the transmitter that it thinks you want to move. And actually, I think it just defaults to the first one on the list, which is handy here, but you can pick the transmitter that you want to move to that location. In this case, it happens to be the first one on the list. And then you've got your latitude, longitude, and this got an option. You can either create a duplicate of it, or you can just move it entirely. If you do not check this box, then it is actually going to move the transmitter, and there will be no record of where it previously was or anything. If you do check the box, it's actually going to create a duplicate at this location. So sometimes you may want to do that if you have an interest in keeping the first one around. So I'm going to go ahead and check that and say create a duplicate and say OK. So it's set up our call sign as KSUI_dupe. For duplicate, and it's set our coordinates to the point that I clicked on, and it's loaded the elevation from the FCC database, and it kept the above ground height of the antenna the same as it was at the previous location. So if I go ahead and hit OK on this, you'll notice I get a transmitter token there, and up here at the top it went ahead and recalculated. So if we say yes to that, it's going to show us what it calculated for that. And it went back to our default color set, so you can kind of see the two different things. So one of the things, and this is, I had mentioned this, these check boxes over here determine what's plotted on the map. So let's say, we just want to look at our duplicate station. We don't really care about all these other stations for a second. What we can do to do that is we could go through and check each of these and turn them all off, which of course is a lot of busy work. And that's why there's this all or none button down here. If you click all, it's going to select all the transmitters list. If you click none, it's going to deselect them all. So we can hit none and then just select the one that we're interested in. And if we do a map redraw now, we're going to get an area that just shows this station. And you'll note we still have this effect going on with the border here. Now one of the things, if you look closely, you'll see this border that's plotted on the map doesn't exactly line up with the colors. And typically when you see things that don't line up for that, it's usually because you're using two different kinds of map data. And just to real quickly show how you can get into what's being plotted, if you click on this map features button up here at the top, and then go over to the datasets tab, this is where you select what is being used for that. And in this example, it is actually using the state data. So, oh, okay. I think that difference may be at river there. It's not actual signal. Yeah, I think that's probably the Mississippi, which is why it looks like it's going over. If we turn off our lakes and rivers, that'll probably go away. Yeah, so you see now it is actually following the border. That was a lake that was getting plotted on top of the map that made it look like the signal was there. Okay, so I had somebody send me a question here in the chat window. They say, can you explain the highest signal report in the pop report window? And I can explain that. That is, I'm going to select all of these and I'm going to go back into our transmitter color plot. So here we're in our transmitter color plot where each station in the study, or whatever station has the highest signal at a point, that it's color coded by that. So if we go into report, and I believe it's under the if we just go into our regular population report, and then there's an option down here at the bottom, highest signal report. If we generate one of these, and then it's going to ask about this common area threshold dB. Like before, I had this 6 dB. I'm going to leave it at 0, so it's just going to not worry about this common area thing. And we're going to count the population here. This study hopefully won't take too long. Yeah, unfortunately, this study has a lot of transmitters in it, and it takes longer. But essentially, what this is going to do, if we have time for it, is generate a report that shows, what is the population in this yellow area here, and what is the population that's in the red area, and what is the dark blue, and what is the light blue. So each transmitter is going to show the total number of people where that, the total population of the areas that where those stations have the highest signal. And the difference between that and the superstation is that, for the superstation, it combines those all and looks at it as one station. Um, unfortunately, yeah, since we've got people watching, um, and it looks like it's probably going to take this about 5 minutes. I don't think we need to sit here and watch this. So I'm going to go ahead and actually stop the program. Um, let's see here. And it says, do I want to save first? And on this one, I am going to go ahead and save it. Yeah, it didn't like that because I killed it while I was doing something, but that's all right. So we're going to go ahead and restart here, and I saved that in case we want to go back to it. But I'm just going to go through and run a new study real quick here. Sorry, I'm running through this real quick here so you guys don't have to watch too much of this. I'm going to say no. And now I'm going to duplicate this like we did before. Let that recalculate and say yes. Okay. So now we've got a more simple study where we've just got two stations that are calculated. And if we go back into our transmitter color plot, it's going to plot, where this one is higher, it's in blue, and where this one is higher, it's in red. So now if we go into report, population and highest signal report, this one will complete much faster, and we can talk about what we're seeing. All right, so here is our report. So essentially, what it's showing here then, it comes up with count area, KSUI, and the duplicate area as population, area and housing housing units, and then it also has the common area, which, so basically it's just telling us that, our KSUI, this area in blue here, if we want to know, what was the population of the area in blue, it's 525,000. If we want to know what was the population of this area in red, it's 515,000. So if we were to just run a normal report and treat these as one superstation, we should get around 1 million, because you should get the sum of these two. It's 525 plus 515, 1,040,000. So that's essentially, that's really all the highest signal report is. It just shows you, it gives you a pop count representation of what you see on the map when you run one of these highest signal type of studies. So I hope that answers your question. I think we've only got a few minutes left here. If anybody has any other questions, you probably should send them to me now, or you can just go ahead and ask. Here's one. With respect to calculating area of a station's coverage, is there a way to exclude areas that are over water? The only way that you can do that would be to do something similar to what I did earlier, where we were limiting using the Iowa polygon. So if you're talking about areas over water, like if it's over the ocean, you could make a polygon out of that state. Say you're in Florida, you could load a Florida polygon and then limit the pop report to within that polygon. That way it would, and along with the pop, the area goes along with that. So it would only count the stuff that's within that. As far as bodies of water like lakes and that type of thing, unless you want to define those manually by drawing the polygons on and then creating a overlap region that essentially excludes those areas, which you could do. It'd be a little work, but you could do it, and then you can limit the pop report to that. So it's basically kind of the same as what I showed before when we were limiting to within Iowa. And then let's see here. Is there a way to outline the counties of an MSA and put a Longley Rice over that outline? The MSA data, I believe if we say add to map and polygon set from data, we actually do have an MSA data set here where we can load these out of the 2010 data. So like for example, the Waterloo.
Hey John,
Cedar.
before you get too far down on that,
Sure.
I was just basically, I would have the counties, that's Arbitron, or excuse me, Nielsen, and what we do, you know, we're a radio company. We have regular broadcast stations and MSAs, and a lot of times almost everything I do is, you know, coverage relative to the MSA. So
yeah, okay, so you don't really want the census MSA, you want the ratings area.
No, and I could list the counties. Is there a way to create a county roster and then put a polygon around it? An outline around it that I could edit?
Yeah, here's what you can do. I'll show you.
Well, Cedar Rapids would be real easy because Cedar Rapids only has one county, and since you're in that general area, Lynn County is the only MSA county. Sure. Or I guess we could kind of create one with
that's
Lynn
what I'm saying. We can look at our map
Cedar Rapids and Iowa City,
Sure. So let's say
why don't we just pretend
Lynn
that Cedar
County
Rapids
and Jones
also
County.
includes Iowa City? Oh, sorry.
Yeah. Anyhow, so just for the sake of showing you how this works, I'll take Lynn's County and then Jones County, and then Jackson and Clinton County. Okay. We'll just add those together just to show you how it works. And the way you would do that is you can go to Map and then add to Map and Polygon Set. Similar to how we loaded that Iowa polygon earlier, you'd pick from data, and then here you'd want to select 2010 county line data, and then you would just type in the county you want. So we were looking at Lynn County, Iowa, and now we've added that to our set, and then we also wanted to do Jones. So I've added Lynn, and I'm gonna say from data again, and I'm gonna type in Jones. So Jones County, Iowa. I'll select that and hit OK. And then we also wanted Jackson, so I'm just gonna do this again. Let's say Jackson. A lot of Jacksons. Just also of note on this list, if you wanted to, if you were in a situation where you wanted to add more than one polygon, you can actually select multiple ones in the list by holding down the Control key or holding down the Shift key to select areas. In this one, I don't know if that really makes a lot of sense because these are all not next to each other, but sometimes that's useful. So I'll say Jackson, load that one, and then the last one was Clinton, and I'll load that real quick. Clinton. Say OK. Pick OK. So now we've got these 4 counties added in there. And so I'm going to go ahead and tell it to fill those in red. And I'll say OK. And you see it put the outlines there. So it's grouped those. And actually I want to check this lock points in place too, so we're not moving our. So it's grouped those into one area. And if I do a map redraw, it's going to show. It's showing those in red, but it's actually underneath the signal right now. So if I turn our Longley Rice signal off, we'll see the area that we're talking about. So here we've defined this, and the program looks at this as being one big area, right? And the name it gave it was Lynn because that was the first one we put in there. But we could do whatever we wanted to. So we'll just say ratings area. You can call it whatever you want. So now, for example, if we wanted to create a pop report for KUSI and just include the area that's in this polygon set that we've defined, the way we would do that is we would just go to report and population, and we pick our database, and we want to pick this only count area within overlap region. Oh, and of course we don't have it there because we haven't defined that yet. So there's one more step we got to do here actually. So we defined our polygon set. We also have to define an overlap area, just because the pop feature works with that and not the polygon set. So we're going to say create new overlap region, ratings area. We're just going to put that in there. I don't know, I'm going to fill it in with orange just so that it's separate. We can verify that. Okay, so now this area in orange is still what we're interested in. So now if we go into our report population, we pull down on this list, we've got our ratings area overlap region that we just created. We pick our pop database and hit generate. And then this is just going to tell us the Longley Rice 60 dBU population that is within that overlap area. Does that make sense?
Yeah.
Okay. Yeah, so it's a few steps to get there, but it can be done.
Okay, so basically I first create a roster of counties in the polygon properties, and then go ahead and put it on, and if I want to put a Longley Rice over it, I would just create the Longley Rice, and then I'm sure there's someplace in there that I can order the polygon as one level, one layer, and the Longley Rice data as another, something like that, right?
Yeah, essentially,
okay.
you need to add. You use this add to map polygon set to define the polygons to load those out of the database, and then you need to use this contour overlap region to actually set it up in the program as a contour overlap, even though it's not really a contour overlap. You need to define it that way so that when you get to the pop counting, you can tell it just to use that area.
Okay, I got that, but here's my other question.
Yeah.
Is there a way just to outline? Okay, you defined 4 counties. Is there a way just to put a border around those 4 counties and not necessarily have the county lines in the middle?
There isn't.
Just the outside. Just make the 4 counties a polygon and have an outline around it.
There currently is not a way to do that. What you can do, yeah. Well, what you can do to sort of, get that feel anyway. If, like, for example, I set this polygon setup. If I change our draw style to none, it's not going to draw the border, but it's still going to have. Let me turn off. I'm going to turn off this plotting of the overlap area. Okay. Okay, so we've got our polygon in here, and it's being plotted underneath the signal. So if we go into map and say signal display options and say plot signal transparently, this will give us a way to kind of see the signal and the county, at the same time. Now, this isn't an ideal choice of colors. You'd probably want to use like.
What if I use no color? Would I get an outline with nothing in it?
Well, you're never going to get an outline. You could conceivably, by using this transparent trick, you could get it to kind of show where that area is. Say, for example, if we go in here and make it a real kind of light gray, and then redraw that way. You can kind of subtly see, maybe make that a little darker to make it less subtle, but by playing with it, you can kind of separate them that way, but there really is no... Outside of just tracing,
create a border.
Yeah, outside of just tracing around the outside right now, there really isn't a good way to combine those and remove the interior lines. Something I could look at for the future.
But I could create the county lines. I could just have the county lines in emboldened in my choice of widths, showing underneath the Longley Rice. that's something.
and
Yeah. I
that's
mean, I wouldn't make them that wide. I'd make them narrower, and and
you could make
I wouldn't make them broken. I'd make them a solid line, make it narrower, and then that would you could see that under a Longley Rice. Yeah.
Yeah, so like here I made them red or what. I mean, yeah, you can. There's certainly things you can do about it. You can't exactly do what you're talking about, but you can get close.
So I could do it, except I would have county lines all
You'd
the
see
way
the
through
internal borders of the counties.
it. Yeah. Not an aggregate of the. I could still, but if I needed to do that, I'm still going to have to go into another program like Map Info or something and create a polygon around the outside of the aggregate borders of the. Okay, all right. I won't take everyone's time.
Yeah.
That's good.
Okay. And as far as creating a polygon, if you were doing it by hand, you could do it in Probe. But yeah, if you wanted to combine them and remove the internal lines, you'd have to use a different tool. Yeah. Okay, so I had one other question here, which was when you did the superstation pop count, did it count some population more than once? And the answer is no. When you do a superstation count, it looks at the signal, and if they're covered by any of the stations, then it counts it once, and if they're not covered by any of the stations, then it doesn't count the pop point. So you're getting an unduplicated population number there. So with that, I think that's all the questions I had.